Boys and girls, welcome to another chapter for our algebra class. Today we're doing polynomials. We're starting a brand new chapter called Introduction to Polynomials. And so roughly what we're going to be doing today is very easy. We're going to introduce you to these things called monomials, binomials, and polynomials, and we're going to talk about adding, subtracting, multiplying, and factoring them. Roughly speaking, that's what we're going to do today. It's going to be a super easy day today. We won't do anything fancy. Just get to know the language a little bit, the vocabulary. So, talk is cheap, let's do it. What's a monomial? A monomial is very simply a bunch of things being multiplied together and not added or subtracted. That's what a monomial is. So this would be a perfect example. By a bunch of things, I mean one or more. So here you have a 3 that's being multiplied times the x, and of course the x has an exponent 5, which means x times x times x times x 5 times. If you look at this, you see no addition, and no subtraction. That tells you that all you have is one item being glued together with times, with multiplication. That's what we call a monomial. A monomial is one item being multiplied together. And you could take that monomial apart, and there are different pieces to it. We could say, let's explore the anatomy of a monomial. Usually this thing is, sometimes you may have a letter here. Usually these are called variables. They usually represent some other quantities. So they're called variables. That's called the variable. And if there's an exponent here, this is called the degree. The degree for the monomial. And this, of course, if there's a number being multiplied times the variable, this is called the coefficient. So altogether we would say, well, 3 is the coefficient, the monomial is degree 5, and x is a variable. The variable is x, the degree is 5, and the coefficient is 3. Okay? Now sometimes you may have a different degree. This one, the variable is x, the degree is 2. A fancy name for saying degree 2 is, we say that it's quadratic. That's another way of saying degree 2. And of course the coefficient here is -5. It's a perfect example of a monomial. You don't see any pluses or minuses there. You shouldn't interpret it as a minus. This is a -5. You don't see any pluses or minuses partitioning the expression. Another perfect example of a monomial. The coefficient is square root of 7. The degree is 3. This one may not look like a monomial, but it is. We say that this is degree 0. The coefficient is 31. We call it a constant monomial, and it's perfectly fine. A lot of times people will write it like this for completeness. We will say x to the 0 is equal to 1. That's the definition of a 0 exponent. And so we will say, well, that's the same thing as 31 times 1, which would be the same thing as 31 times x to the 0. So often you might see a 31, but you can think about it, if you like, a 31 times x to the 0. So that makes it degree 0, or the constant term. Sometimes it's called the constant term. Constant meaning that it doesn't get affected when x changes values, or when x is set to a certain value. We don't care. X is still, this part of it is still 31. So that's a perfect example of a monomial. Okay. Fractions are okay. That's a degree 0 monomial. Degree 0 because there's no x, or if you like, you can say that this is 3 over 5 times x to the 0. So there you go, degree 0 monomial. Alright, so much for that. Let's take a look at binomials. Binomial is exactly what you might think. It's two of these ones, two monomials, and they're being added together. This is a monomial, this is a monomial. Together they make a binomial. That's what we call a binomial, two pieces. You see, this is crucial. This is the partitioning, the bookmark that sets things apart. Anytime you have a plus or a minus, that's separating terms, and so that's separating your monomials. Another name for monomial is often a term, although there's a subtle difference, but we'll get to that later. No, we'll get to it right now. I told you we'll get to it later. Well, right now is later. Let me explain something. For our purposes, we will only call polynomials if these exponents are natural numbers. For example, a 5, that's okay, that's degree 5. But if you have 3x to the 2.71, that's not a natural number, so we won't call this a monomial. It's still a term, but it's not a monomial. For us, Monomials, which make up polynomials, will only have natural exponents or 0. No other exponent is allowed here. You have to be able to write it with a natural number. Natural number means 1, 2, 3, 4, all these, or 0. Together they make what we call the whole numbers, the fancy W. These are the only exponents allowed if we're going to have polynomials or monomials. Okay, so this is a perfect example, degree 2 binomial. Easy, another degree 2 binomial. You look for the highest degree among the terms, and that's your degree for the binomial. You see I have two terms here. They're separated by the plus here. So that's degree 2. That's another example of a binomial. Alright, so enough of that. What's a polynomial? Well, a polynomial is just many of these monomials. Okay? So, x cubed plus, you see I have 2x cubed, I have a 5x, and I have a 1. I have three terms, 3 monomials. So this is called a trinomial. We say this is a trinomial. And the degree for it, well, this is degree 0, this is degree 1, and this is degree 3. So the degree for the whole thing, degree 3. This is called a degree 3 trinomial. Okay? Pretty easy, right? Okay, how about this one? See, I have a term there, a term there, a term there. I have 4 terms. How do I know? Because they're separated by these separators, which are the pluses or the minuses. In this case, I have 4, so it's called a quadnomial. Or people just say, they just say polynomial. After a while, a bunch of them, all of them together into just one group called polynomials. So this is a perfect example of a polynomial, and we would look for the degrees here. Degree 0, degree 1, degree 2, degree 3. So the whole thing is degree 3. This is a degree 3 polynomial. 1 is a constant term. 2 is the degree 1 coefficient. 5 is the degree 2 coefficient. 11 is the degree 3 coefficient. Okay? Just some jargon here. Here we have another example of a polynomial. And this one has 1, 2, 3, 4 terms. The constant term is -5. The linear coefficient is 1. Even though there's not a 1 there, we know that multiplicative identity says that that's the same thing as x by multiplicative identity. So 1 is the linear coefficient, 5 is the degree 3 coefficient, and 11 is the degree 5 coefficient. Highest degree is 5, so the whole thing is degree 5. So recall when we learned about integers. That's things like -2, -3, 5. When we learned about them, we first learned that the -2 is the additive inverse of 2, and then we learned how to add, subtract, multiply, and handle all these integers properly. The not theorem and whatnot. That was one of the chapters, chapter 2. Then we did that for fractions, 2 over -3. That's the world of fractions. We define them first, and then we learn how to add, subtract, multiply, reduce, etc. for fractions. Today, what we want to do is the same thing for polynomials. Polynomials are things that have x's, and they have a bunch of monomials being separated with pluses or minuses. What we want to do is learn how to add, subtract, multiply, and factor, and manipulate them, etc. That's the name of the game today. And so, let's get on with it. Let's start out with something easy today.